Awkward Wave and hello. Today I want to go over setting up supports for my MOI 130 and let you see the tips and tricks I go through to make what I make. It seems that according to the forum that I've been able to make successful prints where others have not, and I want to share some of the steps that I go through to do exactly that. So without further ado, let's get right to it. On my desktop here, we're going to go straight to Meshmixer. I have Meshmixer set up to be what opens all STL files. So right here, it says Import Sphere. I'll give you a link to download Meshmixer if you do not have it already, to make things simple for you. I'm going to import a sphere because that's the simplest shape. There are other shapes here that you can snag at will to put in your workload. Just hit accept once you have the size right. So I'm going to stick with the sphere. The MOI loves organic objects, so this is a great place to start. So I'm going to edit this and transform it so that it is a shape that I want. You can change the pane angle by holding down both Alt and Shift on the keyboard, and then use the left mouse button to move it around. Once you have your object ready to go, one of the things you want to do is check your dimensions. Now we're going to go off of the assumptive dimensions, ergo the results that we want to get. And if they are correct, just accept it and move on. You can do alterations in here. If you are using a custom piece and you want it to be larger, if you have uniform scaling on and you want this to be, say, 100 millimeters tall, it'll change all dimensions reactively. Easy as that. We're making a small piece for today, right? 40 millimeters. Now, with it in place, checked size, we're ready to start doing the work that we want to do. Now, I always start with Meshmixer for a couple of reasons, and they may not be clear at first, but one of those is that it is a great mesh manipulating utility. One of the things I want to look at, I always look at, is I open up the inspector and I want to see if there's any purple or red orbs. There are none. Don't need to worry about that right now. Another thing that it will allow you to do is hollow. Hollowing is actually quite good in Meshmixer. It makes a high poly interior that allows me to manipulate it a little bit better. I can also use Meshmixer to manipulate the interior shell independently, which is a great feature. But for now, we're just going to make it hollow using this as a basic step. 2 millimeters is a great place to start. You really don't want to go below 1 millimeter, but you can get there. One of the things that you'll learn while printing with an SLA printer is that thin walls cause warping. So you don't want them to be too thin. Doesn't matter how big the object is. An exception to that is solid geometric objects. Believe it or not, this will print at 1 millimeter just fine. And if I cure it with a clear or I print it with 100% infill, I'm not going to have much of an issue. I can use this to add holes as well. And while you're doing the hollow, it is as simple as double clicking. You can double click again to remove. And let's say I want to have a small hole. Since this is a small piece, a small hole is desired, so I'm going to do a 3/4 millimeter hole. Update that hollow. And then when we click, our holes are much, much smaller. Being smaller, you probably want to increase the number of holes that you have especially if you're going to use PO poly resins, because PO poly resins are notoriously thick. Now, once you have them dragged into place, we can move on from there. Now, there are, unfortunately, sometimes issues with making these holes, and these issues will arise no matter what kind of slicer or manipulator you use. It's just going to happen. Right now, I don't even know if this is going to accept these holes, so we're going to say accept. We're going to see what's going to happen. I've got a hole up top, I got a hole on that side, and I got a hole on that side. That's actually pretty good. In many cases, you try to do that, and the holes will not appear. What they'll do is they'll appear on the inside mesh and not the outside mesh. That's just an error, and you can quickly Control-Z that and try again. 1 millimeter hole, update hollow, accept. It is hollow right now. Oh, there we go. With no holes. Just in case you're wondering, that striped strata right there on the inside, that's a reversed normal. That means that that is the inside face of the polygon, and you should not see it. If you do see it, that's a different problem. Okay, so let's export this. It's going to be my oval. Oops. Going to be my oval hollowed. Now, I can do more in Meshmixer, so I always start with it. And we're going to do more with Meshmixer once we're in Cura, show you another trick. All right, so since that's all I needed right now from Meshmixer, I'm going to go ahead and close it. So just as a recap, I use Meshmixer to orient, scale, and hollow. And now I'm going to go to Chittoo Box. I want to show an alternative with Chittoo Box to help you out. Okay, so there is my piece right there, looking great, bright as rain. Chittoo Box has a slide scale right here on the side, which allows me to take a slice and see the inside of the piece. This helps especially with large, complicated items, because I can take a slice of the entire thing and view just that area to inspect. This is especially useful when I'm going to dig a hole. So once I click Add Hole, it's going to give me a green little spike that's showing me where it's going to go. Choose right there. That looks good. These are the air holes where air is going to go into to allow the resin to drain, but they're going to start off as anti-suction holes. So that way when the peel force from the resin vat as it lifts from the build plate to generate the resin for the new layer allows the resin to flow on the inside without delaminating the FEP or PDMS layer. So having two holes on the bottom, and of course the bottom is illustrated by that large triangle. Did I say triangle? That large rectangle. Know your geometry, sir. So this is going to be the first area that gets built. This is where it's going to need the weep holes. All right. So with that done, let's go to the top. Using the opposite mechanic, so I can see where the best place to put the drain hole. The drain hole is going to be the hole that allows resin to flow out of once it rests at the complete position or the raised position. When it's done printing, it goes to the top and resin drips off of this. And if I add the hole to the right place here, it will be able to drain out and leave less resin on the inside. And this also helps for when you clean it, it's going to get alcohol on the inside. This will help drain it as well. So when you set up your model, there's an error. So when you set up your model, make certain, this is a big deal, make certain that when you set up your model, you have at least 2 holes, minimum. One as a drain, one as a weep. Okay, there it is. There's the hole at the top. That's the drain hole. And we know that this is all good, right? There's our sliced view all the way to the top. Okay. Next phase. Save as. That is my completed hollow with holes. We're ready to go on to the next step. Now, the next step can actually be done with any of these programs. B9 Creator is a great program to add supports. Asura is another great program to add supports. And so is Chittoo Box. We're already in Chittoo Box, so we're going to go ahead and do this here. Here's our support list. And the first support I'm going to add is always going to be heavy. Heavy supports for the first contact point on your model. And in Chittoo Box, here we go. It's the red area. That's the area that is going to mandate supports. This black ring showing us where the parallel levels to the build plate are as they rise. So I know that this area, right where that disappears, is going to be the area that needs a support. Also, you'll notice the little gray dot right there. Chittoo Box has already told me that if I go for automatic support generation, that is where it's going to put it. And we're going to need to make this for platform. There we go. This is the automatic support generation from Chittoo Box. I don't like all of that, but it gave me the first one. Actually, I like those position on those two. But I don't want them to be so large. We're going to go to medium now. We're going to pop one about here. Let's add support. Pop one about here. And we can tell that it's on the same plane because of that black ring. Pop one there. Now, as you'll see, that gives us a sail, a perpendicular sail that rises out of the build plate or rises down from the build plate, however you want to look at it. And it's got one thick chunk and 2 smaller ones. These smaller ones will keep it from swaying in this direction. Well, what about this direction? That is why I did not keep the support generation that it started with. We need to get a few more supports on here. It recommended at minimum 4 by the automatic support generation and those gray pegs. That is a great place to start. In fact, I think it needs 2 more out here just for suction resistance, because as it builds more and gets closer to that outside edge, about here is where it's going to have the highest pull force from the entire model, because it's the largest area. So having these extra 2 pieces on there is going to help resist the pull and keep the model on the build plate. Now for left and right deviation, I'm actually going to have to go a little bit higher. See that gradation of the red on there? I think I'm going to go from the middle, from where the red is and where the red stops. That's good enough. And I'll make it asymmetrical. There we go. It's actually not too bad. I could add more. I could give this more attention, but that covers the basics. I am a little bit worried as this rises higher. There is potential that putting a support there is going to be helpful. And this part comes down to experience. How many supports, how far apart they are, and how far they rise on the model. It has its ups and downs. At a first glance, one of the biggest problems of putting too many supports on here is how they remove from the model and cause errors. Well, I already have 2 weep holes here on the bottom, so putting a few extra supports in there is not going to hurt anything. And that is why I have 1 support here, or not 1 support, that's why I have 1 piece here. That's a drain hole at the very top and a very easy to clean spot that also is a very minimal worked area. So the question is yours. And let's just say we're going to put one way up here, way up there. The only problem with that is that all of this area does not benefit from that at all. So from here, if you print and from here up, you get less Z-banding, but from here down, you get a lot of Z-banding. Well, 1, it's your resin probably is gelling and not printing solid enough. 2, you probably do not have enough supports. So since that is an irrelevancy, I am just going to delete them. If you want to add them, keep them close to home. That is really too many supports. It really is. But that should keep it smooth while printing all the way up. Feasibly, if I made that 1 support at the very bottom large enough, I wouldn't need any more supports. Well, we're going to keep this. We're going to pretend it's perfect. Save as will allow us to export the STL. And since this is one with supports, in Chittoo Box. Save. I can go ahead and close this. What's the next one in line? Are you sure you want to quit? Yeah. Asura. Let's import a model. We need to be able to drag and drop in Asura. I mean, please. All right, here is our hollowed model. Support generation in Asura is a lot easier. A lot easier. It's also more uniform, and I like that. The density here, from 4, I do it at 2.5 because it is a small model. You could change all of these. They all mean something, and you could just play with it, add your support, play with it again, see what happens. All slicers have what is known as the angle. This angle assumes that past that angle, no supports will be done. So that way you don't get supports in the top. There is a button on here that says remove internal. There was the same one in Chittoo Box, and I didn't go over that. What this means is that no supports are generated on the inside hollowed portion of the model. I do have models where that is mandatory. And if I do not do it, the model will fail. So on this model, I do not need internal support. So I'm just going to click generate. And there we go. Clear, generate. Well, it's actually a very interesting. I didn't expect this result. So this is actually very neat to look at. It's got the bottommost portion, I think. No, it doesn't. Look at that. It's missing one right there. So it doesn't have the bottommost portion, and it rises in this beautiful symmetrical position. The support placement is beautiful, but we missed that. How did we miss that? Well, we're going to have to click add. We're going to have to put it right there. And another thing that we don't have is, since it is like a sail, that's great in one direction, but we don't have the sail action blocked at all, so we're going to have to put some more supports on here. What I'm going through in my head is how, as it starts from the build plate, the very bottom, and starts to generate this, right about here where it touches. This is where we start getting into the model, and it starts rising. We've got some wonderful supports, and then right about here we have no supports. So this area right here is generated off of the support structure we already had. Then these supports will start to add in. This will help stabilize it. And then it goes higher, and then we have these two stabilizations, and then all of these supports work to stabilize the rest of the model. And what I am looking at, what I am in my head going over to see if this is enough or if I should add a few more. I want, and I am stuck personally, one of the things that I go through is an issue of minimalism. Whenever I generate supports, I go through a thought process of absolute minimalism. And at sometimes that bites me in the ass. At other times it matters not. So the question right now is, will that pull for support minimalism bite me in the ass? You know what? I won't know until it's printed. But from experience, let's not fight it too much. If that's a knee-jerk reaction, and you're worried about it, work to solve it. It is sometimes easier to dial back from too many supports than it is to try to push someone to make more supports, because you need to get over the fear of using too many supports and making a mess down below. The option is a failed print. Too many supports, the worst thing that will happen is the supports will fail and the other ones will do their job, and you'll start to see that you didn't need those supports in the first place, but you have a successful print. So what do you want? A print that failed because of too few supports, or a print that succeeded even though it has too many failed supports? So let's keep it simple. I'm fighting the angle of too few supports. Okay, with that done, I am going to save this with supports from Asura. Hello, B9 Creator. B9 Creator was the original support system generation that I was introduced to. I used B9 Creator for probably half of the printer's early life. And it's also great because in B9, if I see that my supports in Asura had failed, I could come in here and add new supports on it. So, our support list, we've got custom tiny, light, medium, and heavy. One of the great things about this is we could change the shape to a nice, large collection of various types. Defaults are fine. They work very well. And when I'm doing very tiny miniatures, there is a lot of tiny supports on there. They succeed. So, given that this is going to get its first print, and oh look, I get my little white line. It's actually thinner than it was in Chittoo Box, which I'm more fond of the B9. Woof! Hello, Chungus. That's a big boy. Alright, let's modify this one. Select it, and make your modifications. I want that bottom to be smaller. There we go. I could change the thickness of the shaft, I could change the cone type, I could change all kinds of things, including making that cone look a little bit less terrible. There we go. I know that Chittoo Box does this. I have not tested it in Asura, but it is a fun thing that I like to play around with if I need a little more distance on the support or a little more of whatever. It allows me to play at those numbers quickly, live. No matter how many supports are on there, I could have 30, 40 supports on there and it'll work. Back to the support tree. Now, if you go all the way to the bottom, there we go. Look at that. transparent butt. So I'm going to go to medium supports, and I'm going to add one there and there. Cone looks nice and thick, and that's going to be a huge workhorse for our workload. As I mentioned before, my tendency of minimalism on the supports plane means that I have learned that I can get away with this. However, there is one thing you want to keep a lookout for. Notice this right here. When the bottom of the contact point on the model is below the support end point, there is a potential of failure at the contact point. So, though I am certain this will print just fine, that error gives me a little warning bell inside my head that says I probably need to add something a little bit lower right in between just to make certain that these succeed. There we go. Now that endpoint is definitely below, just like the rest of them. Go to modify, bring it in. And there's our art sculpture supports. I could add a couple of more in there to keep it symmetrical. Since there is no kill like overkill, let's go ahead and do it. Doesn't that look like it would just succeed? You've got a nice tree on the bottom with minimal peel force. It's a raft technically. And once it gets past that raft, if it prints the raft just fine, you know the rest of it's going to succeed. And I can actually get rid of that raft completely if I wanted to by adjusting the diameter. But I think this is fine and it should succeed without issue. When you do a lot of supports, your raft gets bigger and bigger and bigger. And you can have fail points because the raft did not allow a release from the FEP. That is something to be cognizant of. So raft minimalism is another aspect that you have to be cognizant of. Asura is bad about raft minimalism. It makes gargantuan rafts that cover the entire scope from 1 to 2 points and everything in between. So B9, that is why I like to play with it. It allows me to minimalize the raft and to keep thinking about it and work it through the thought process. And it's taught me how to make supports. Now this tree, that's going to be fun. This model is going to print, as I predict, with little to no problems. I think it's going to be great. Okay, so that's done, as we can see. In case you're wondering, B9 Creator has a mod that you can import to create a Moai base, because this base is not sized for the Moai. It's a lot smaller. I could have models in here a lot larger than it, and it'll be just fine. Again, that's another reason why I like to start in Meshmixer, because I know the dimensions and how and where it should be aligned. With this done, let's export it. File, export. Supports B9. Now, if I were to make a comment on this, support minimalism at its finest. Some funky tree-like growth of supports. And millipede legs. Now, out of these, which one do you feel the most confident in printing? It's a mighty good question, isn't it? I'm pretty confident that all 3 of these will print. And it'll be a test, and that's a fun test to do. But I still gotta say, me personally, I just love the B9 supports. There is just something about them that I like the most. Seconded by the Asura supports, because when you get those, a brainless, monolithic number of supports, generated automatically, and you just go in and fine-tune them. I've done that a lot. Chittoo Box on simple supports or on simple models. Chittoo Box on complicated models. Between it and B9 Creator, it's kind of a toss-up for me. However, for your workflow, you may find that Chittoo Box being a one-stop shop just for you may be all that you need, and that's all you ever need to worry about, and more power to you. Go right ahead. Between the three of these programs, you should be able to generate supports without question, without fail, pick up the faults of one to improve them, and make your life much less problematic. So if I were to say, if I needed to generate an extra support in any of this, it's kind of a toss-up. I want to do it to both Asura and Chittoo Box. So I'm going to go back to B9 Creator. Let's add our model, Asura, first, because it is in alphabetical order. There it is. Beautiful blue. Let's go to the support tabs. Notice that how it is raised a little bit. And I'm thinking a little light line right here, just to be cheeky. For some reason, I think that'll help improve the quality of the print overall. Only one problem about moving the panning along on this one is it automatically adds a support when you do that. All right, let's modify these and clean them up a little bit. And B9 allows you to modify, so I could just boop, 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 add them, and boop, 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 modify them. So much simpler in B9. Okay, so here's a cute thing that you can do, is you can actually insist upon model collision on your supports. Just like that. In the same purpose, where you have those angled lines in the back here on the Asura model, you can force those intersections and collisions upon supports, improving the structural integrity and the rigidity of supports. That is why on the B9 Creator, when I generated the supports, I started bringing everything in together and starting having them all touch. It creates a stronger, unified base that has fewer problems down the road. So this boy right here, I can actually double up on him. Yeah, let's make him the thick boy. Look at that. And let's get cute, because can. And let's make a cross beam right there. There we go. This will also create a moment where if one of these 4 supports fail, there is a high chance by the time it gets to the intersection, the supports will recover themselves. When you're doing a lot of little supports, that is something to be absolutely cognizant of. And if you do, and you do this, you will see at the base a support failed. It goes up, hits the intersection, recuperates, model printed successfully. You want that. So with this done, and in fact, I could take this and pull it out here. Yeah, look at that. Look at that bad boy. Sitting way out there. Way out there. Uh-oh, but that's a different problem. Let's go back to models. Change that Z height to 0. Bam, right back to the build plate. And now, modify, please. Thank you. There we go. Let's modify the bottom on that one for a radius of 0. There we go. That's the fun thing about B9, is I could do all kinds of things like that. This is still modified in Chittoo Box, or I'm sorry, this is still modified in Asura initially. Because I also did it in B9, I make that note. Before we get into Cura, I'm going to show you how to recover an incredibly poorly optimized mesh. This file. Pull that straight out of the zip. This file is a mess. Now, it doesn't look like a mess. It looks just fine. There are some odd red lines. Those are mesh errors in read. This could be because of file format conflicts. Say it was an OBJ file, we converted it to STL. During the conversion, those splines are not necessarily connected, but they're so close, it's irrelevant. That is why they show up as this red line. But as you get closer and see that it's highlighting a complete face, there is no reason to worry about it. If you see those, generally you can ignore them. However, from experience, I know that this model is a mess. I'm going to go over here to separate shells. This is a disaster of a decision on a model that is supposed to be one mesh. Lo and behold, this is 81 individual pieces. It is not a solid mesh. So here is the first thing to look at. I just moved 2 pieces. I'll keep one side on. It looks solid till I did that. Now imagine, if you will, if I tried to hollow this. There are so many non-contiguous pieces. Hollowing is impossible. So this STL file has confused the generator to make it think that this is one piece. They just happen to be touching. Their physical contact with each other is an irrelevancy. They are individual pieces being fooled as one. Now then, plane cut will allow us to see the interior. Just as a quick inspection, there is an error there. There is an error there. Oh, look at that. Look at that. The butt end of this isn't even connected. Not even connected. That would have failed, and that is something we probably would not have noticed or looked for. I could show you how to get into Meshmixer and a very complicated sortie to fix that problem. I don't like complicated. I like simple. Welcome to simple. Let's create a new design. Here it is. Here's our workspace. Simple shapes. This is exactly like Meshmixer. In fact, it is the same company as Meshmixer, except this is an interface for a complicated setup simplified. A minute later, here is our model. Just like Meshmixer, we can pan around, we can tilt it, view it, take a look at it, and understand that Tinkercad, because it was told so, also thinks that this is one model, one mesh, but it doesn't look like it. You can see the lines of separation. Doesn't feel like it. We're going to have to do something about that. All right, step number 1. I'm going to import you. Yeah. Let's move this 90 degrees. And let's get... What? There we go. I need to make sure this is lined up well enough. This is snapping to every millimeter. I probably want more of a resolution out of that. There we go. There's a little bit of collision on there. It's not bad, considering that there was absolutely nothing before. Oh, that needs to go over this way. This is our savior tonight. We're going to go from no contact to absolute contact. Okay, problem number 2 is that this was very, very not solid. So I'm going to fool it into being solid by creating an interior. That's too big. There we go. I can't see it. I can see it there. No worries. There they are. Look at them. They have collided on the inside to meet one another. And though this looks like a hot air balloon with some sort of weird funky mask on it, that is a great way to think about it. What I have now is a piece that is going to be treated as a binding agent? I think that's a good way to put it. It's a binding agent. That blue piece that I just put in there is going to make a section where all of the separate pieces crisscross, and it's going to join them to be one piece. And we're going to do it with one button. Select and drag all 3 of those shapes. And there's this button right here. Group. Boom. One button. Okay, there it is. You can see the blue is gone. Considers that all one piece. I've got my center in there. Thankfully. Let's go on the inside. There it all is. There is no more. You can see some remnants of some of the odd collisions on the walls, but there is no more multiple object syndrome on the interior. Suddenly, I have just solved a huge problem that would have been a $150 a month fix for the more advanced programs. I did this for free. Tinkercad.com. Create an account. This is free. And that, what I just did, is probably the most powerful and sought after tool in the 3D printer's arsenal. Let's export this to an STL. We're going to open it with Meshmixer. That was really easy. Okay. I don't need Tinkercad anymore. You can go. Don't save. Here it is. Now it looks different. That is an interpretation on the model. What Meshmixer is trying to do right now is determine where edges are. And because the model is a little complicated, it is confusing it. In fact, I'm going to go over here to View Wireframe and show you that all of that confusion and all those odd shading patterns are along these lines. You'll see some details you didn't see before this way. This kind of answered some questions. It's not a mess as it was before. It's the same as it was before. It's just that now all of these parts are combined, which it wasn't that way before. In fact, this whole area at the top right here, this cross, whatever you want to call it, was a separate piece that sat on top of the model. The wireframe hasn't changed. It's just the interpretation of the wireframe's connections that's changed. Remember, I combined everything. It now thinks that this is one solid model. Now, hopefully, that's correct. I'm going to separate shells. It's going to think. It's going to process. It's going to churn. Look at that. It's thinking. Boom, okay. Now with that, we could see that it has 110 shells. Awesome. That is the difference. These are the errors that were there before. There are 109 errors. That is on the inside of the model. In fact, I'll do this. You can see it. That was on the inside. Those are the separations. Those are the other things. All right. So what I'm going to do is I'm going to take this one piece, move it out of the way of all of that confusion and all that mess, which is mostly being highlighted by the blue, but there's 109 pieces floating around in there. Oh, I hate having to think about that. I'm going to delete them. Bye-bye, pieces. Bye-bye, mess. Get out of my life. I don't need you anymore. There it is. My one piece. All right, let's put you back. Edit. Transform. And roll out. Accept. View. Recenter view. Boom. Okay. Now, when I go in the inspector, these are what it thinks are the problems. But this is what I mentioned before as being a conversion error. Let's see what happens if we start fixing these. How about that one? Boom. Nope, that fixed just fine. How about this one? That one. Nope, that one was no good to remove. How about this one? Looks good. This one? Oof. Control Z. How about this one? Nope. This one? Nope. How about this one? All right, so there is fewer errors on here. So let's see what happens if we hollow. My goodness. There it is. Hollowed. Okay. So, well, that's interesting. You can see how it's interpreting that. That's a box of some sort right there, and it's made this little divot right there. No worries. I understand how it's interpreting that and why we're getting the error. Okay, so the beautiful news is that it now thinks that this is manifold. All I have to do is tell it where I want the holes and move on. All right, so there it is. Edit hollow. I'm going to make one hole here because that being the butt end of the whole thing is where it's going to drain the easiest. And then two here. Let's accept. Oh my goodness. I've tried to print this before doing that, and I did not have this kind of success. This is a beautiful success. In fact, you want to see what kind of mess that was initially? Let's export this. Head hollowed. Let's take the original head. Let's replace. Let's take a look at it. Edit. Hollow. Okay, here it is. There's my hollowed mess. Let's take a look at some of this. There's a lot of blurring and occlusion in here. Well, let's try to add a hole. Well, that was the bottom where I tried to add the hole last time. Got nothing clear on there. All right, let's try it. There we go, 2 holes. Same hole. Look how blurry it is. This means that there is a lot of intersecting hollowed, non-hollowed structure. That is why we're having such a hard time seeing through it. Let's accept it. Let's see if it doesn't even crash. I bet you it will crash. Oh, it did it. 1 hole, no holes. Look at that. That's so weird. Well, we know why it's doing this. I've already talked about it. Look, I can't even see through that. Hollow. Not hollow. So we have some problems on this model before that would have prevented us from getting to this stage. This is ready to be oriented and supported. This one is going to leave you confused, frustrated. You're going to fight it. You're going to keep trying to put holes on there. Take it to Tinkercad. Put things on the inside. Make it manifold. And you can, again, when you go to Analysis, Inspector, this one still registers errors. It's very, very hard to get a complicated model with no errors. But it still registers errors, but they're different errors. And as you play around with those errors, you begin to understand what it's interpreting. As in this one, remember those red lines I talk about? Errors in codes from transforming the file type from, say, OBJ to STL or even back again. Where this one is because it is so many different models. So let's done. Let's go back to edit and separate shells. No shells found. You'll want that answer. Edit, separate shells. And this is where we get to the crux of the problem. This is why I love Meshmixer. This is why I use Meshmixer. It lets me see things that I normally wouldn't have seen or understood what was going on until I did this. So being able to inspect the model with these simple tools is going to perpetuate so much further, perpetuate you further than you. It's being able to examine these models with these very simple tools is going to help perpetuate your models to being so much better. Well, with that, I think we're done with this first part of the model. The next part will be me getting into Cura, and we're going to be mounting these to print.